Have you ever wondered how major online services keep your data safe and always accessible, even when things go wrong? It is not magic, it is smart design. Data replication strategies are fundamental techniques to create and maintain multiple identical copies of data across different locations. Their primary purpose is to ensure high availability, fault tolerance, and durability for critical information systems. Replication guards against data loss and service interruptions from hardware failures or outages. We can categorize these into three core strategies: synchronous, asynchronous, and quorum-based replication. Synchronous replication means data is written to all replicas before the write operation is confirmed to the client. This offers the highest level of consistency, guaranteeing that all copies are identical at all times. However, it can introduce latency, as the operation waits for all acknowledgements, potentially impacting performance, especially over long distances. It is ideal for highly critical data where even a tiny data loss is unacceptable. Asynchronous replication works differently. The write operation is confirmed to the client as soon as it is written to the primary replica. Copies are then updated independently, often with a slight delay. This strategy offers higher performance and lower latency, as the client does not wait for all replicas to be updated. The trade-off is the potential for minor data loss during a primary node failure, as some unreplicated changes might be lost. It is well suited for disaster recovery or less critical data. Quorum-based replication involves a configurable number of replicas that must acknowledge a write for it to be considered successful, and a configurable number of replicas that must agree on a read. For example, a system might requiring 2 out of 3 replicas to confirm a write and 2 out of 3 to confirm a read. This offers a flexible balance between consistency, availability, and performance. It allows fine-tuning for specific application needs, managing trade-offs more granularly. Choosing the right strategy depends on your application's specific requirements. Consider your recovery point objective, or RPO, which defines the maximum acceptable amount of data loss measured in time. Think about your recovery time objective, or RTO, which is the maximum acceptable duration of downtime. Evaluate network latency between data centers, the performance demands of your application, and the criticality of the data. For example, financial transactions usually demand synchronous replication, while website analytics might tolerate asynchronous replication. Understanding the concept of a replication factor is also key. This is simply the number of identical copies of data maintained across your system. A higher replication factor inherently increases fault tolerance but also incurs greater storage and network overhead. Many distributed systems leverage a replication factor of 3 for a good balance of durability and cost. By carefully analyzing these factors and selecting the appropriate replication strategy, you can design resilient systems that consistently deliver data availability and integrity, forming the bedrock of robust back-end operations.
If this helps you code smarter, like, subscribe, and stay tuned for more.